In ProtoLink's A2A Jury, 5 AI jurors vote. 2 output guilty, 3 output not guilty. Then they talk directly. 1 output changes and the verdict flips to guilty. Did one agent convince another? ProtoLink's replay shows exactly what changed and exactly what it cannot prove. This is the AI Liability Tribunal, a fictional, replayable courtroom built inside the open-source ProtoLink agent framework. 12 addressable agents run the hearing: a judge, 2 advocates, 4 witnesses, and 5 jurors. The jurors have different professional role prompts. That creates different instructions, not 5 independently trained minds. The published harness compares solo, independent, 4-person star, and direct mesh conditions. The clearest contrast is independent versus mesh. After the same public hearing, Sophia and Ruben output guilty. Annika, Evelyn, and Malik output not guilty, 2-3. The independent condition stops there. The mesh opens direct routes, giving every juror one turn to address another. The simulation engine schedules one bounded round and tells each speaker which recipients the topology allows. The speaker authors structured public data: a target, an action, a message, cited evidence, and a short statement of intent. The application validates that move, wraps it in a ProtoLink inference task, and calls the receiver's addressable endpoint. The receiver returns a public register: vote, confidence, citations, reason, reply, and optional triggering message identifiers. No private chain of thought is exposed. The system records public outputs, application state, and a numbered event for every exchange. Now replay the published deterministic Seed 7 mesh. Sophia Bell, the 4-person, speaks first. Sophia targets Annika Rao and attempts persuasion using exhibits 3 and 7. Her message connects an unvalidated C91 calibration with the changed crash scene map, then questions why both reached production. Immediately afterward, Annika's register moves from 77.9 not guilty to 81.41 guilty. That one categorical change turns a 2-3 minority into a 3-2 guilty majority. This is the experiment's central result. 4 later messages shift registers by -0.58, +5.48, +3.54, and +2.95. None changes another vote. The mesh therefore ends with Sophia, Ruben, and Annika guilty, Evelyn and Malik not guilty. But this is not convergence. The mean guilt register rises while polarization also increases, and reported consensus gain is negative. Each event stores sender, receiver, message, citations, and the receiver's register immediately before and after delivery. The report aggregates those after-message shifts into directed influence edges. A receiver may also cite a triggering message identifier. That makes influence inspectable, not causal. Changed after is evidence of sequence. It is not proof that the message caused the change. The strongest limitation is the provider. This published run uses courtroom reference v2, a deterministic fixture, not a live frontier model. Its updates are calculated from message wording, evidence weights, receptiveness coefficients, and seeded noise. The effect was engineered to be visible. So the replay proves the tracing machinery works. It does not prove deliberation improves accuracy or that guilty is the better verdict. With live models, different roles still may share training data, prompts, retrieval, and failure modes. Multiple outputs are not automatically independent evidence. The same route carries a persuasive false claim as easily as grounded evidence unless citations are checked against the record. And once one shifted output influences the next speaker, feedback can compress dissent into false consensus. For any agent jury, preserve every first answer before discussion. Without that baseline, influence disappears into the final vote. Then rerun paired seeds with the decisive message removed. If the flip survives, that message was not the whole cause. Yes, one agent's message can precede another agent's changed output. The useful capability is not consensus. It is auditable influence.